Good afternoon.
And welcome to the session on release management and containers being the key ingredients of successful DevOps. My name is Ognjen Bajic, and here with us is Ana Rajovancic. We come from Croatian company Ecobit. Let's start with a couple of questions. Please raise your hand if you've worked in production with release management, in VSTS or TFS. 1, 2, 3 hands. Okay, please raise your hand if you just tried it or played with release management in any way. Okay, much better. Thank you very much. Who has worked in production? Well, nobody. With containers, meaning Windows containers. Who has played with Windows containers so far? 2 hands. Docker. Who likes Docker? Great. No more questions about that. So, a couple of sentences about us. So Anna and I have been working with Microsoft's ALM tools since the beginning. Way before the first release was released 10 years or so ago. I remember installing our first TFS on Christmas 2004. And we both have the background in development, but we've also played various different roles throughout our careers. We've been testers, we've managed test teams, we've been project managers of a classical kind, we've been release managers, scrum masters, or product owners. And we believe that such varied experiences are critical when we discuss the topic as DevOps, such topic as DevOps. And I've been Microsoft's ALM MVP since 2006, and Anna has recently been awarded MVP as well. So our today's agenda. We'll start with an overview of 3 main topics, being release management, containers. Actually, most of the time we'll be talking about Docker and the DevOps. And we'll discuss the benefits developers and IT operations can get from containers. And we'll discuss how you can use release management to build the automated pipeline. And we'll end the session with a longer end-to-end demo of a demo people tracker application. This is the URL for it, for already deployed version of the application, where we will change something in an application. So make a change in the source control, commit it, push it. We'll use a pull request for that to make it a bit more fun. And as soon as it gets merged in the main branch, it will trigger a continuous integration build, and that one will trigger release management pipeline, and that one will do lots of funny things that we will observe and analyze later. Okay, let's start with DevOps. So there are many definitions, many opinions about what DevOps is. But right now we are more interested in what DevOps isn't. To name a few, DevOps isn't a tool that you can buy. DevOps isn't someone that you can hire to solve your DevOps problems. DevOps isn't a team that you can organize within your organization, DevOps team, that will deal with DevOps for your organization. DevOps even isn't developers and IT operations working together for the greater good, because it's much bigger than that. DevOps encompasses the whole organization. Whoever has some stake in the development process, be that business owners or business analysts or the development, testers, IT operations that run your software in production environment, and basically anyone that has anything to do with your software that you deploy to end users has to play together in order for your DevOps activities to be successful. So let's try to define DevOps as a union of people, processes, and the tools with one main goal: to optimize the flow of value to your end users. And we'll simplify things, but we'll define 3 cornerstones of DevOps. The first one being the culture of sharing and collaboration. The second one being continuously optimized lean process. And the third one being the automated release pipeline. We'll discuss all of them throughout the session. And you shouldn't forget about that. DevOps isn't about developers and IT operations. DevOps is the whole organization working together as a one with the sole goal to optimize the flow of value. Optimize that you basically deliver to your end users. Once again, people, processes, tools. Maybe the biggest transformation that you need to go through in order to implement DevOps is the cultural shift, is the change in the culture. You should have collaborative culture of sharing where, okay, let's go with devs and ops. They should work together. Developers should have operations when there are production errors. Operations should sit on the meetings where developers discuss architecture for the next version, because at the end of the day, they will run that new architecture sometime later in their production environment. And there are additional shifts that should take place. Instead of fear of failure, instead of trying ways to avoid failure, you should embrace failure. You should deal with the fact that you will fail. Sooner or later, you will fail. And instead of being scared of the day, you should be prepared and be able to fail fast and move on, fail forwards. And that's what you will be able to do with automated release pipeline based on release management and containers that make it easy for you to produce small chunks of features, small pieces of functionalities, and deliver them in a rapid pace. And obviously, in order for your organization to nurture collaboration, you should get rid of organizational silos. Automation, another pillar of DevOps. You should have automated pipeline where you automate your builds, your testing, your deployments, everything. And that pipeline should be the only way for the changes from your version control system to the production environments. Actually, to all the environments. And the changes in your version control system, they are obviously not only the code or the SQL database or whichever database you have, that's also infrastructure described and managed as a code or whatever you have in the version control. So you should version control everything and have pipeline in place to put that to production. And ideally, it will be automated all the way to production. But that's not necessary. So if you have a manual step somewhere at the end, approvals for the production, that's okay as long as there are automated pieces of that pipeline that put your changes at least to some testing or pre-staging environments so that you have automated tests run over new features, over new code, so that you can be sure that if you want to release, that you'll be able to release. Ideally, it can be automated, but needn't be. Okay, some additional DevOps values. Lean. Ideally, you will have lean process where you get rid of wasteful activities by continuously analyzing what you're doing wrong, and at the end of each sprint, or on a regular basis at least, getting rid of something that make your process wasteful. And by deploying small pieces of functionality more frequently, you'll get better control over the risks and more robustness in your process. And that's doable by separating deployments and feature releases by using feature flags. And last but not least, you should measure everything in order to understand yourself, your process, your software, and your end users. Okay, so that was the very quick overview of DevOps. And now we'll hear Anna and release management story.
So thank you, Angel, for this nice introduction about DevOps and its scope, the culture, the general changes the team should embrace. And now we move on to release management as one of the main mechanisms that allow you actually to put DevOps practices very easily in place in your own organization. So when we are talking about the notion of a release management pipeline, then we are talking about a sequence of different stages, different environments you use in your development process in order to deploy and test your application multiple times. So you surely have a development environment and you surely have a production environment. And in between, you should have a number of different testing environments that, as you move towards the production, are more and more similar to your production, so that each next deployment brings you closer to the production environment, and you test the new version that gets deployed in a better way, in a more serious ways. For example, in the development environment, you would have some unit tests, while at the end, in the pre-production environment, you would already let your users do some final user acceptance testings. What release management allows you is to model a repeatable, automated deployment pipeline that meets two main goals. The first one is the fact that you take a single build and push it down your release pipeline. So you are not building each time you move to the next environment. You are using the build you build once, and then the version you build once, and then push it through the deployment pipeline to production. And the second goal is that release management tools allow you to model a process where most of the actions are automated. The whole process is repeatable, is very reliable, and it's quick comparing to any kind of manual installations. So, in other words, it allows you to do your deployments quickly and multiple times, because you need, in practice, to test many versions before you produce the one that actually goes in production. We are talking today about release management in Visual Studio, Team Services, and TFS, Team Foundation Server. So if you are already familiar with the tool, most of you raised your hands when Ogden asked about release management in general. So I suppose you have seen the user interface. You are using build, you are using maybe work item management, the agile tools. This solution integrates very well with the rest of the environment, and is so the whole all you have generally at your disposal in TFS, the same artifacts, you can make use of them while working with your releases. So with release management for VSTS, you can create a continuous deployment solution. This tool allows you either to fully automate or semi-automate your release processes, meaning that at the beginning or end of some stages, you can have approvals, meaning that the person actually can come and approve the success of a deployment in the previous environment and approve the start of the deployment in the next environment. Also, in the background, data gets collected. So you have logs, you have detailed information about each step in each environment for each and one release instance, so that you can later on either analyze your releases, search for errors, and that is also very important for regulated environments where you have very high audit standards. So what we have to our disposal in VSTS. So we have the release management service that runs either in the cloud, so on VSTS can run either in the cloud, or you can have your own TFS on-prem installation, sys update 2, that also allows you to use release management service. You have the client. Currently, we can only use the web client. The REST API is coming very soon.
Actually, sorry, Anna, let me interrupt you for a second. We have a breaking news. The REST APIs have been just published, the documentation for the APIs, so you can go in the MSDN and read about the REST APIs.
Yeah, thank you. And if you have already used the build system, then in behind the same agents and the same pools are used, that they are either in the cloud, so you can use the hosted agents provided by the VSTS, or you can have your local agent installation. That mostly depends on the requests of your build and release process. The hosted agents are not fully at your disposal, and you cannot further configure them, while when you have an on-prem agent, you can do whatever it takes to build your particular bits. Environments, you will see in our demos, it's easy to model environments, and it's easy to configure particular properties per each environment, and you can map the environments either to virtual servers or virtual machines in your local infrastructure, in the cloud, as we will demo today, you can use containers. Before moving to our first demo, let's take a look at the release management pipeline from a higher level. So what do you actually need to do to create a release management pipeline? You need to define your environments, so how many different environments you need in your software development process. By defining your environments, you define your release path. Then you need to produce servers that will stay behind this environment. So in each environment, for each environment, you need one or more servers. These can be, once again, either locally or in the cloud. And then you need to define the steps for each environment. So actual actions that will be performed to deploy and test your version in each environment. I've already mentioned you can define different settings that then play a role when we actually run our release instances. And at the end, once you have a release definition, you trigger each time a particular release instance. So let's move to our first demo.
4.
Okay. So this, what you are looking at, is the user interface. So here I'm on the release hub in VSTS, and I am previewing the results of my last release instance based on our demo release definition. As you can see, we will be using 3 different environments, dev, QA, and production. And during this and our following demos, we will see how this definition looks like. So 3 environments. In each environment, you have a sequence of different steps. In our particular scenario, we are using an Azure SQL database, an Azure web app, and we are using a Dockerized web front end. On the level of each environment, you can do different configurations. This is the place where you set your approval logic. This is the tab where you define which queue is used in behind. We are using our queue that's already been set, and we are using a local agent that is running here in the background and waiting for release requests. Okay? About variables, we will talk later on in our last demo. And then about deployment conditions, this is one of the newest updates that has been shifted. And here on the level of the development environments, you can see that this environment starts with the deployment after the release has been created, while in the QA environment, we have a different deployment condition saying that the deployment in this environment can go further on only when the deployment in the development environment has successfully finished. So that's all for our first demo. Are we ready to hear a little bit more about Docker?
Sure, yeah. So Docker and containers. Containers are lightweight runtime environments. The main thing about them is that you have your software together with all its prerequisites within one unit of isolation, within a container. And so that gives you reliability. Basically, you know that all you need is being deployed as a unit. And one special thing about containers, they are immutable. So we won't install updates in the running container. We'll throw it away and create another container with a new version. And that brings some completely new concepts in the release pipeline when we have containers, and we'll discuss that later. Containers look the same everywhere, meaning wherever you run them, they will run basically as wherever else. Local on your local PC or somewhere in your local environment or in the cloud. So they are very portable. They are blazingly fast. You can start a container in an instant. And they should be considered as a unit of deployment. So you you execute one container. But then what if you have a solution that is being built from multiple pieces of software? You have a multi-tier solution, front-end, back-end, middle tier. Then you will have multiple containers connected with each other. Let's compare VMs and containers. That's the usual story. You should know about it, but probably you've heard about it. In each copy of a virtual machine, we have the whole copy of the operating system, whereby containers usually share their kernel, their copy of operating system with the operating system of the host, which makes them much more lightweight. So you can have many more containers running on the same hardware than you would be able to run virtual machines. And it's easy to run multiple instances of a container, whereby you can't easily run multiple instances of the same VM without network isolation. Okay, so what are benefits of Docker and containers in general? So developers can easily start a container. So they can easily get their own runtime environment in which they can develop, which they can use to test. Create a container, run tests, throw it away, go on with your life. It's easy and it's fast. And they can easily be deployed to your local environment, to the dev environment, to QA environment, to the production. The same container or instances of same container image, which makes procedures standardized, which makes deployments more robust. You're doing the same thing based on the same piece of bits, the same container image. And since the same thing is being used in the production as well as in the development environment, if the problem happens here, you'll be able to reproduce it in a development environment easily. No more no repro, which is powerful mantra. And there is no way for settings within one container to do a damage, to clash with the configuration of another one. They are units of isolation, which is perfect. So, and okay, well, they are pretty explicit, meaning when devs and ops use containers as a language in which they speak to each other, they can easily collaborate using such a language. So, with all these benefits, containers make DevOps nirvana. It's beautiful to have DevOps once you have containers. Okay, so what does the workflow look like if you have containers? You can develop on your local container on your local machine, and then create a so-called image, container image, which is a template which you can instantiate and create a container. And that's what the IT operations guys do. They instantiate, they run containers in various environments, ranging from dev environment to production environment. And they monitor the behavior of containers running in those environments together with the developers, and based on the results of the monitoring, developers can plan next iteration and work on the next version of those images, and so the circle moves on and on. Okay, well, we've been mentioning Docker. What about Windows containers? There will be Windows containers. In Windows 10 and in Windows 2016, when they are released, there will be production-ready version of Windows containers. And there is preview available today. Actually, for months it's been available. And there will be two versions of Windows containers. Windows Server containers, which are lightweight. They really share the kernel with their host. Hyper-V-based containers, which have a layer of Hyper-V isolation between them and the host, which is good for the robustness of the whole system, but costs a bit. They're a bit more heavyweight. Unfortunately, they are still not ready for prime time. And that's the main reason why we will do the demos with Docker. Expect a lot from Windows Container in the near future. So what does the work with containers with Docker look like? What's about Docker API? So we have our client. We have Docker host, which is a machine where Docker daemon runs. And there we have containers, right now none, and images in local image cache, obviously none. And there is global repository of images. And we say Docker pull, and an image gets pulled from the registry, Docker hub. And we say Docker run, and we have running container. Okay, so that's about running one container. How about having multiple containers connected to each other? Remember the multi-tiered application. It's easy to do that as well. And the command line tool is called Docker Compose, and its use is Docker Compose YML file as a definition of what we need to be done. And without further ado, let's see containers live. Okay, so the first thing that I'll show is Docker run hello world. And containers will greet us, hello from Docker. Basically, it's useful. It's not just play, because here you can see it works. And we can expect more. So let's see more of Docker Compose YML. What do we have here? We have Web API, which will be the first container, and front end, which will be the second one. Web API based on .d web API. The first being the name of Docker Hub account, the last being the name of an image there, and the latest version of it. It will open the port 5000, attach some volumes, and so on. This is the image for the second one. Some environment variables will be set, and it will listen on a port 83. 83 doesn't have any special meaning. It's just for this demo. And front end is linked with the Web API. Okay, let's see what it really looks like. And the command is Docker Compose up, and -d means detached, run in background. So we have two containers. Let's play with them. Port 83 for the first one, and port 5000 for the second one. So this is the people tracker application running in Docker containers, a local version that we may use for development, for instance. And the people tracker application, apart from being so nice as it is, helps us track people. And it uses REST API from this address, and that's the web API from the address of the second container, to manage the names and first names and last names of people. First name, last name, and here it is. And if we open port 5000 and refresh, here they are, newly created entries. Okay, so let's move on.
Mm-hmm.
So what you've seen was Docker Compose, with which we can create multiple containers connected to each other. It's fun. You can have multi-tier applications in an instance. It's beautiful. That's what containers are for. And we have Docker Compose YML file, which defines what we want, and it's easy. How about scaling out? Yes, it's nice to have front-end and back-end, but I need 5, 10 more of front ends and multiple instances of middle tiers and load balancer in front of them and backend and whatnot. So this is the simplest version of the architecture. Let's put some more in this architecture. More front end, load balancer in front of it, more middle tier load balancer in front of it, and so on. Okay, so you got the message. And it's easy to do that as well. Just do Docker Compose scale. Let's see what it looks like. So in this demo, we have, once again, we have web frontend and Redis backend. Redis, who knows what Redis is? Please raise your hand. So it's structured data repository. And it's readily available. We just say, OK, give me a container based on image Redis, and we're done. And basically, our UI talks to Redis and counts the number of clicks on it. OK, let's instantiate these two guys. OK, once again, we open the browser and open the front end on port 5000, and let's play with it a bit. And it counts, and that's it. Not much to it. OK, let's move on. Let's scale these two guys. So now we have web frontend and Redis and load balancer. Load balancer will run on port 80, and web will take the port 5000, but it will just expose it so that load balancer can link to it. And we use readily available images for load balancer and for Redis, and we have our software from the previous demo for the front end. OK. Let's check whether I can create them just as this. OK. Now we have 3 containers. And this is what containers look like. So this is the Redis one, our front end, load balancer. OK. So this is simply a tool that lets us watch the desktop of those containers. And port 80 is where the load balancer listens, and it works. OK. And we can see those entries here in the web. OK. So far, so good. Let's scale. Let's have 5 front ends. 1, 2, 3, 4, 5. That's it. And You don't need to trust me, you can see. And let's play with it. 1, 2, 3, 4, 5. What will happen? We have a load balancer. It will balance for us. So, did I do it well? I played with port 80. And what did it do? Here. And this one got a couple of requests. This one got a couple of requests. The requests were distributed over those containers. And that's what the load balancer is for. OK. And the last but not the least, your customers have gone away. The shop is closed. And you don't want to pay for those containers. Let's remove them. And after a while, they can start much more faster than they can stop. But they're gone. That's it. Scale up, scale down, containers. OK. How can developers benefit from Docker and containers? Well, they can easily create containers, which is what we've just seen. And they can have their runtime environments. They can collaborate easily. They have containers as explicit language to talk to operations. And they scale well. We have seen that. It's easy and natural to build microservices-based applications using containers. And once you decide using microservices, then you get additional benefits. And since within a container you have your software together with all its prerequisites, you are sure there's no way for problems with configuration. OK, Docker tools for Visual Studio is the next interesting thing. Who has installed Docker tools for Visual Studio? I have homework for all of you that haven't raised your hand. Please do that as long as you use Visual Studio. Because with Docker tools for Visual Studio, your projects from within Visual Studio will work nicely with Docker. Let's see. This is Visual Studio. This is a project. Let's start it in IIS Express. This is just something created, ASP.NET Core application created by using Wizard. With some additional magic so that it can tell us that the operating system is Windows NT, it means Windows 10. OK. Let's move on. Let's click right mouse click, add Docker support. That's it. And all of a sudden, you can use Docker. Isn't it nice? Let's use Docker. Well, we can use Docker here. And actually, we can use Docker because it added a Docker-related files. Remember YML. And you don't remember because we haven't described it. And Docker files have especially interesting roles, but we don't have time for that. So let's start our software in Docker container. 2 or 3 clicks is all that we needed to do that. OK, in behind or in front, in a later version, and the team has been delivering rapidly. This is a 3rd version since end of February, and we can expect another version very soon. So this piece of PowerShell running in front end will be hidden relatively soon. But basically what it does, it creates a container and opens a browser with a session on a port where that container is listening, and we will see our application in the browser. Why this container hasn't been so fast as those previous ones? We don't have any words, but please suggest an answer. We are debugging it. It's heavyweight. And my Docker host running on this laptop is actually small Ubuntu Linux machine with less than gigabyte of RAM and just one core. So it's burdened and it almost dies under the heavy burden of these containers, but it works. It's Linux. Ubuntu. But there's more. Let's close these things. They've been generated for us. Probably Microsoft knows what to do, so. Hello. So I've changed my one CS/HTML file. And nothing happened. Hello from Docker after refresh. So we didn't have to create a new instance of the container. We didn't have to deliver. Visual Studio tools for Docker have connected our source with the code running in a container. Ain't it nice? But there's more. Home controller CS, much better than CS/HTML. So remember Windows NT, Ubuntu. But we want to thank Docker as well. What did I do? I changed the code, a CS file. Ooh, .NET in Ubuntu, hopefully. Let's see. So, nothing changed. We have to refresh. Let's refresh. Connection refused. Must be security. Security is answer to everything. Let's see what's going on in the container. We can see. Ooh. It's working. My poor container is doing its best. What's going on? So we are in a debugging session, and that's not your usual container or your usual piece of software running in a container. It's more. It combined our software with something that watches over it, a caretaker, so to say. And it found out that we've changed the piece of source code, and it redeploys our software in the container as we speak. If my Ubuntu were a bit more powerful, it would have been faster, and this is all demo level hardware. And if we wait long enough, maybe the security won't be an answer. So let's wait a second or two. Oh, no, it's done already. Sorry. Ubuntu and Docker playing together. In Ubuntu's name. Thank you. So IT operations and Docker, well, if developers can benefit, why wouldn't IT operations? And yes, they can benefit from Docker and containers once Microsoft releases Windows containers. They're portable. They can be put everywhere, and they will run the same wherever we run them. And they are standardized runtime environment. And standardization is good because we can standardize procedures which we use to deploy them. Through standardization, we build efficiency, robustness. Our the deployment processes are better. And you can have more density. You can run more containers on the same hardware. You can use different platforms. We like Ubuntu. That's new Microsoft, and so on. Release management is another topic.
So let's connect further on containers with release management. If you remember on one of the first slides, I told you that release management allows you to take one build and push it through all your environments. This means that you need in each environment to install a new version of your application, and although you are testing it, you are sure that it works, it might also not work. With the containers, which have a change in philosophy. So the container your developer uses on his local machine is actually the same one that will be finally running in production. So here, when you move through your environments, instead of updating containers, you simply throw away the old version and use the new one. So it's as simple as that. The container workflow looks like this. So we have a local development environment where your developer does its development, debugging, everything packed into a container. And when the changes are ready to go further on, you move the code changes to your source control system, from where you can have a continuous integration build set up that will prepare your images, compose them if you need such a thing, and prepare the whole new the changes for further testing. When you are ready with the container or with multiple containers, you move them in your registry, either in the public Docker Hub registry or in your Azure private registry, and from them, comparing to our previous deployment pipeline, instead of using build, you are using containers. So the same containers get deployed in each environment, only using different settings. So you are configuring your containers based on the requirements of each particular environment. So once again, these are the components: local development environment, source control, continuous integration and build, and continuous deployment or release management system. And what you can use today from tools, you saw Visual Studio, Docker tools for Visual Studio, Visual Studio Code. You saw that maybe the ones you attended in the session where our colleague talked about Docker also. You have Visual Studio Team Services, so the whole tool set, including build and release management services. I've mentioned the Docker public registry. If you don't like that, you can use the Azure hosted private registry that hosts only your images, and then you have you can use the infrastructure also based on Azure resources. Pretty soon, Microsoft is working very intensively on that. Docker tasks will be available. In our demos, we don't use them. We still use PowerShell tasks that were partly generated from Visual Studio and partly configured by us. In these images, we are using the same Docker commands as Ognjen already showed you in the demos. This new task or more tasks will allow you to simply compose, to use Docker as you can use any other release management task. Okay, finally we'll come to our end-to-end demo. Once again, back to the people tracker application. We are using from the point of infrastructure, so we are using VSTS, we are using our Git repository, we are using the Docker Hub, and we are using Docker containers. We are running our Docker container in a virtual machine in Azure, as well as the other two service components, so the SQL and the Web API. Our runtime infrastructure consists of our Dockerized front end, so a web app running in Docker, of a web API running somewhere in Azure and an Azure SQL database, and we will be using free environments, meaning that in each of these environments, all of these 3 components will be deployed. The development scenario from the demo will be that we are going to develop a new feature. So we are using Git, we are doing local branch, merging our changes to this local branch. On the other hand, pushing them to the global repository, merging them with the main branch using a pull request. And then in the background, we have set a continuous integration build, meaning that a build will automatically trigger once a change is checked in the main branch. This build will build the code, run some unit tests, prepare the Docker image, push it on the Docker Hub, and additionally copy some artifacts on VSTS that we will later on use in the release management process. The release management definition is also set to be continuous deployment, meaning that after the build finishes, it will automatically trigger further on with a release. We have also set all approvals to be automated so that the demo goes faster on, so we don't have to actually approve in between environments. And what about steps? So in each environment, we are deploying the database, the API, and our Dockerized web app. And in the development and the QA environment, we are additionally doing some testing. So let's see that in action.
So I know that you're eager to see our people tracker application because it's marvelous. And we promise to have 3 environments in which it runs. So the development environment, and this is the development environment. We basically have front-end, web API, and SQL Azure in each environment. And this is the URL for the web API. Remember that web API from the local demo that was running in a container on a port 5000. That's the same piece of functionality, but now in Azure. And these are people that we track thus far. Here, that's a QA environment. Once again, some demo users there. And this is production environment. And there is a user in the production environment. So this is the already deployed version of application. As you can see, we manage first name and last name. And if we go to the code, we can see that in our database, in our SQL script, we have first name and last name. In our person class, we have first name and last name. Let's do some developing. Development, we use Git for the development. Git status, it says nothing. Nothing has been done. Let's do some development. Okay, so I'm quick. And let's check with Git. It knows everything about our code. And there are 10 changed files. I trust myself. And as you can see, I have changed the database. I have changed the person class as well. And so the city should be there. And the changes are here. City. And we commit and push. Okay. And we go to pull requests. And kindly ask for these changes to be merged in the main branch. Okay, please allow me to be merged. And since I trust myself and I'm the only one to review this merge will be going fast. Okay, and what's the next step? What will happen now? Build. Let's check if that's true or not. Build is running.
Okay.
Build is running, yes.
So build started. Let's take a look. Okay, it's running fast. That's nice. So let's take a quick look at the tasks. So here we are building our solution, doing some unit testing, and pushing our image to Docker. Additionally, preparing some artifacts used later on for the release management process. Okay, is it? As you can see here, so each particular step is logged later on. For those of you who maybe haven't seen the build and release management solution, all these logs are available for review and download. For example, here, okay. Okay, we are currently pushing our image to Docker Hub.
So what does the build do? Builds the software and produces the image and pushes it to Docker Hub. And that image will be later available for the release process.
Okay, we need to wait for a few minutes.
And as Anna has already described, we'll use the same image and deploy it in each of the environments.
Let's move on to our release definition in the meantime. Okay. So this is the part where you set it to be continuous deployment. So once this build is finished, it will trigger this release management instance. Here you can configure variables on the level of the whole release management, and you can additionally preview the variables on the level of each particular environment. So here, as you can see, we are using different websites and different servers in each particular environments. These variables will be used while replacing the tokens in our configuration files. Okay, what's the status of the build? Still running. Okay. So this is the task that replaces the tokens. This is the task that pushes the Docker image in each particular environment. For example, here you can use the usage of one of those variables I showed you on the level of the whole release management process. Any questions maybe while we are waiting?
Yes. Excuse me? Yeah.
Yes.
Well, right now we are wasteful. We are pushing everything, and that's part of the reason why it's so slow, because
yes,
we are pushing everything that was created by the build. But we needn't do so. We need the Docker-produced image and some configuration files. Basically, that change. The configuration files will be specialized for each environment, and that's what we need. That tokenizer step does the trick that allows us to have the same bits specialized per environment. So the bits are the same, the image that's been deployed in each environment is the same, configuration is different. And the tokenizer bit, the tokenizer task specializes the configuration files for each environment.
Okay,
Where?
so
connection string, basically.
okay, so in the meantime, the build finished and it triggered our release. Let's take a quick look at the deployment in our first environment. So as you can see, we are deploying the SQL database now, and then we will proceed with further steps. I hope that we are close to the end of our session. I hope that by the end we will be able to show you at least the deployment in our development environment.
In the meantime, I'm sure you have more questions.
During the development process, you will produce probably hundreds of Docker images. Is there an intelligent way, and you will need only the last one? Is there an intelligent way to get rid of the images if you produce during the development?
Where locally?
You have even seen me doing that unintelligently during the demo. So yes, I was, during the demo, the first demo in the command line, between first part and the second, while I was showing the slides, in the meantime, I've simply told him, stop all the containers, kill them, remove the images if you want. So yes, there are commands for all of these things, and you can build any logic, any intelligence in it that you like. Any other questions? Yes?
Can you tell us a bit more about the state of Windows containers and how they will compare with Docker?
Sure. So in the end, there'll be no difference in the sense that you'll be able to use Docker commands to work with Windows containers. And a specialty of Windows containers will be that you will be able to use PowerShell as well. You can do that today as well, but for Windows containers that you create with the PowerShell, you can't use Docker commands, and vice versa. And that's just a temporary current anomaly. And in the future, once everything is ripe enough, you'll be able to use them interchangeably. And the state is, well, I have running Windows containers there. It's there in preview. They are simply not. The APIs are not stable enough, and so on.
Oh, we are not lucky this time.
Okay.
I'm sorry.
So repeat the deployment.
Or show maybe just a previous one.
What? No, repeat the deployment. Or say that you should be deployed in QA.
Okay. But
fail fast, fail forward.
We have some credential error. Okay.
Redeploy. It worked yesterday. Probably it will work today. If it doesn't, at least we'll have QA.
You need
I don't know.
to trust us.
Well, we have the pipeline. If it doesn't work, the problem is in the pipeline. We'll fix the pipeline, and the next deployment should go on.
Okay, would you like to finish with the slides, or?
Okay, so we'll watch the pipeline finish its work later, and it will be available, at least in the recording. So let's review what we've seen. We've started with the story of DevOps and the fact that it extends the agile principles from the development team to the level of the organization. And that the culture of sharing and collaboration is necessary to have successful DevOps. And as you have seen, containers and release management can help with that. Release management can be used to create automated deployment pipeline. And fail fast, fail forwards, hopefully it will fail forwards, is easy because everything is automated. If it fails, put it once again through the pipeline or fix the pipeline. And it should work next time. And you can use containers and release management for that as well. And containers help both the development and IT operations. And we can use them to have lean process where we deliver small batches of functionality frequently with ease. And thus have robust and efficient way to deliver our new features. So, and containers release management help with that as well. So with all of these, you can deliver more frequently, in a more robust manner, with high quality, and basically with confidence, because your pipeline does the work for you. And that's it for high-quality DevOps with release management and containers. We'll be here till the end of the day, or you can send us emails. Until then, happy DevOps and enjoy containers and release management. Thank you.